So my name is Laetitia Petit. I'm a professor at Tampere University in Finland. And with Wilfried Blanc, we are organizing every month a webinar to celebrate the International Year of Glass. And today's webinar is about the entrepreneurship in photonics. And we are very lucky because we have two experts, two entrepreneurs. So Mircea Guina, who is a colleague of mine at Tampere University, so a professor, but also Arno Zoubir, a friend of mine, and we met when Arno was doing his PhD in the US, so you will probably hear about his experience. So both will share with you their experience as entrepreneurs. So Arno will be the first one to speak, and then Mircea. So please hold your question after the two presentations, and then hopefully we will have some fruitful discussion. So Arno, thank you.
Thank you very much. Thank you, Laetitia. Thank you so much. Well, first, thanks for inviting me. I think this is a really nice opportunity to share experience. I understand that the audience is composed of PhD students and master students and perhaps even postdocs in photonics. And I remember that back in the days when I was myself a student in photonics, there weren't so many people around me with background or experience in this field. As you know, it's still quite a narrow field, let's say, compared to electronics or, I don't know, material science or other specialties that we can encounter. So I think this is a great opportunity. I understand that you are also specialists in glass, which is maybe an even narrower field. And I think this is a great thing that you get to hear from people like Mircea and myself, let's say from the real life, what your career could look like a few years from today. So again, thank you very much for this opportunity. So what I will do, I guess I started with a brief summary, but I think you all know the topic. Maybe to remind you guys that photonics is quite an emerging field. However, it's a very dynamic field. It has been categorized as a key enabling technology by the European Commission itself that distinguishes between different branches of science and technology and decides on priorities. And for sure, it's a field that has a lot of potential growth, let's say. I will go a little bit later in more details about what the photonics market is, but this is certainly a field where if you have, let's say, talent or an appetite for entrepreneurship, well, that's certainly one of the best fields to be because there are so many opportunities. I will be mostly speaking about my own experience. I think Laetitia mentioned that if you have questions, please hold them, and I will be more than happy to answer them at the end of the presentation. And I will start with a quick introduction. So this is myself and Mircea. I guess Mircea will introduce himself just in a few words. So I belong to the photonics industry. I have over 20 years of experience in this field, and as you will see, I have quite, I would say, a hybrid background in the sense that I did part of my career in academia and part of my career in industry, and this is what I will detail a little bit further. So my education, as Laetitia mentioned, we actually met in the US at the University of Central Florida. At the time, I was doing my PhD in a center called Creole, which is it's the School of Optics of University of Central Florida. I started by a master's program, Master of Science, and I guess because I enjoyed it and I discovered photonics at this time and I kind of liked it, I decided to go on with a PhD. So I spent in total about 5 years over there. And the topic of my research was the fabrication of waveguides in transparent materials, including glasses, of course, with a femtosecond laser. We call this femtosecond direct laser writing. The idea is that when you focus a femtosecond laser beam, it only works with femtosecond pulses. You create interactions between the light and the material, which change the index of refraction. And if you are able to move the laser spot with respect to the substrate made of glass, in 3 dimensions of space, you're able to fabricate 3-dimensional waveguides. So this was the topic of my thesis. This is actually also one reason why I interacted with Laetitia, because she was at the time working in a glass fabrication lab, and especially focusing on chalcogenide glasses, which are highly nonlinear glasses. And that opens a lot of possibilities in terms of optical communication, optical limiters, and so on. So I guess at that time, I was only doing research and I had very little idea about what was going on in the industry. However, I was lucky that in the US, perhaps more so than in Europe, there are a lot of industrial partners surrounding academic research. My thesis, for example, was funded, partially funded by an industrial partner. So there are a lot of interactions, and I think that's a very good thing, because it sort of guides the research towards something which is actually useful, that can be marketed. And I think, yeah, of course, fundamental research is also useful, but I think in a field like photonics, which is, I would say, in between, let's say, fundamental research and technology, it's very good to have very concrete applications and very concrete needs from industrials. So I later on, once I finished my PhD, I pursued a research project in Australia at the Australian National University. And at that time, I was studying the magneto-optic properties of chalcogenide films. I was still working with chalcogenides for integrated optics. The idea is that when you apply a magnetic field to certain glasses, which have high refractive indices, and in particular, refractive indices that vary a lot with wavelength, you can get interesting properties. I will not get into the details, but of course I have some papers if you're interested. I went on doing research, still doing research at Osaka University in Japan. At that time, I developed a laser system based on optical parametric chirp pulse amplification based on a titanium sapphire laser. And the idea was to produce very intense laser pulses to obtain what is called laser wake field acceleration. The idea is that instead of using very large facilities to accelerate particles and electrons in particular, one can use the electric field of a laser pulse and accelerate these electrons to relativistic velocities. So yeah, that's pretty much the end of my academic career, I would say, because as you will see in the next slide, I later on joined the industry. But I want this presentation to be as useful as possible, so I'm trying to also highlight a few pieces of advice that maybe I can give to you guys. For this academic part of my career, one advice that I would give you is to know as early as possible whether you are more fit for the academic world and the industrial world. I came to realize that the academic world was not for me. It was a little bit too slow paced for me. I really wanted to do things which had, let's say, practical uses, marketable uses. And for that reason, I joined the industry. And it's perfectly fine if you think otherwise and you prefer the long-term, developments of academic research. Both are extremely useful to society. So it's not to say that one is better than the other, but I think it's very good that you know what you really like. And I think I was lucky enough to realize what I really liked quite early in my career. And I think that was a very good thing. One thing I want to emphasize is, at least from my experience, is that once you leave academia, it's kind of difficult to go back. It's probably easier to go from academia to industry than the other way around. So, well, that's one piece of advice. Another piece of advice, which I'm sure you're very well aware of, is try to publish as much as possible. Publish doesn't mean only papers. I think patents are also a good way to publish. Some universities are more open, or let's say give more incentives to students to publish patents than others. But I think in any case, whether you stay in academia or industry, it's a very good thing for you. So it depends also on the maturity of the research that you're doing, but never forget the patent option. And my last advice, I mean, based on this part of my career is, as you can see, I did a lot of travel. That was an absolutely amazing time for me. Now I've become a little bit more sedentary and I kind of miss my travel years. So while you're still young and while you still don't have so many strings attached to you, just enjoy this time. Do some postdocs elsewhere than your PhD laboratory, let's say the lab in which you got your PhD. Just seize any opportunity to travel. That opens a lot of things. You know, it helps learning a language. It helps you becoming more open-minded. You know, it's a great human experience. So yeah, just travel if you have an opportunity is my piece of advice. So I said, it's at this point that I decided to join the industry. And my first industrial job, let's say, was with Horiba. So Horiba is a Japanese company, which is a rather large group. It's, I believe, over 5,000 employees worldwide. And they have branches, of course, in many countries, including France. So at this time, I joined this company as a sales manager. I started as a regional sales manager, and I later became the worldwide sales manager for their research division. I was providing sales training to their representatives, organizing product demonstrations, workshops at overseas exhibitions. I was helping defining the pricing policy, especially for non-standard products, in close relation with the R&D team, and I was supporting affiliate offices in other countries to develop the distribution network of the company. So this was a purely sales-oriented job, I guess, but it was still very close to research. I mean, all of my customers were researchers, PhDs, professors, or researchers in various labs. And my background in academia was definitely very useful for that. So I think for me, that was the perfect bridge to transition from academia to industry. And after 5 years, because I also wanted to change my location at that time, I took another position in a research center, a technology center, they call it, in optics and lasers called Alphanov. This was a much smaller structure. When I joined Alphanov, it was only 10 people, I believe. Now it's more than 100 people. And in a nutshell, technology center, I don't know if you're familiar with these kind of organizations, but they're not exactly a lab, a research lab that does a lot of research, whether it's fundamental or applied. It's not a company either, although it's able to take orders, it has customers, but it's basically a place where industrial companies come to do collaborative R&D. So the companies are the research center's customers, and I was in charge of collaborative projects with academia, because we also work with academic laboratories, industrial partners. We did a lot of laser micromachining, developing new laser structures, architectures, and optical systems. And I was involved in the innovation and marketing strategy of Alphanov, deciding what we patent, what we don't patent, taking care of the technology transfer. I will say a bit more on that topic later on, and managing the sales activity, because again, we did have customers. So I guess for this part of my career, let's say my conclusion, my take-home messages are, pick your first job carefully. You know, don't rush. Be sure this is what you want to do, because it sort of gives, you know, the first impulse to the rest of your career. Of course, you can always, you know, do 180-degree changes, but it's a little bit more complicated. So you want to have some kind of continuity in your career and some kind of coherence. So this all starts with your first job after, you know, PhD or postdoc position. And my last advice is really do what you love. I mean, I'm really convinced after this many years in the industry that people do well what they like to do. So if you want to do well, do something you like to do, right? So yeah, that's not always easy to apply, let's say, but that's certainly a very important advice, I think. Oh, let's talk a little bit about innovation, right? So yeah, innovation is great, but no amount of hard work can compensate for a stupid idea. So I think the keynote here, the key idea is that innovation is all about making choices. Also, I briefly talked about the fact that I work for a technology center. Again, I think the relationship between industry and research is key. And there is this concept called open innovation, in which industrial partners come to other organizations, be it research labs like yours or technology centers, to do their own R&D instead of doing it by themselves, you know, on their own, without any collaboration. However, there are strong challenges. I'm not going to go into the details of the challenges of open innovation, but one of them is that the provider for the innovation, in other terms, the laboratories, are sometimes a little bit difficult to access by the industrial partner. There is this kind of wall, you know, sometimes we feel there are two different worlds. Sometimes the language is even different. And I'm not just talking about being from different countries, but we have different objectives, we have different agendas, and, you know, this can make open innovation a little bit more tricky. But I think this is very key. And if you're in the field of science, you will have at some point to work with industrial partners, and always keep in mind that the goal is to make the research useful to society. And very often research is being made useful to society through commercial exploitation. So just a few words, and I guess I will be soon out of time, so I will try to go fast, but just a few words on the basics of technology transfer, because when I was a student, I had no idea how this worked. I mean, I kind of had a sense, but this was really far from what I was taught or what I was explained. So again, technology transfer means taking some good ideas coming from the labs, academic labs, fundamental research labs, even applied research labs, and taking this technology outside and making it useful for markets. So it all starts, you know, with the top part of the pie chart with research. Then there is some evaluation of this research, of course, and it all goes back to the idea that, you know, some innovation are useless. There is some strategy to decide whether it's useful, how to address a market with it. What problem does it solve? Always keep in mind this question: what problem am I solving? If I don't know how to answer this question, it doesn't mean what I'm doing is useless. It just means you're doing fundamental research, and it will be years before what you're doing can become interesting for society. Then, of course, marketing. You need to find the right way for people to buy what you have to offer. Negotiation is one of the hard parts. That goes back to the technology transfer paradigm, where there's sometimes you know, different points of views between research and between industry. And then there is the commercialization, where as a researcher, normally you don't have much to do, but you might be involved until this last step. So you want to know, you know, this, you want to have this big picture in mind when you're doing research. Oh my God, I still have a few slides to go. I wanted to tell you about my entrepreneur career as well, because I started a couple of companies. The last one was called Goya Lab. So Goya Lab, the basic idea is that in 2015, I guess I woke up one morning telling myself, why don't you make a smartphone? Why don't you make a spectrometer out of a smartphone? I realized that they had great sensors, very sensitive, they cost nothing. I mean, we all have a smartphone in our pockets, and almost everything was ready to make it, to transform it into a spectrometer. So I made a proof of concept, which we called Go Spectro at that time. This is the top picture. This was a little add-on that we added to the camera of a smartphone to make it, to transform it into a light spectrometer. 2016, we applied for a patent, which was granted, and we started the commercialization of what I call a prototype. So it's between a prototype and a product. And you really want to be in this type of field, right? You really want to be fast on the market. You want to be ashamed of what you're starting to commercialize. If you're not ashamed, you waited too long and you spent too much time refining and improving, and you lost a lot of time, and the market is not there anymore. 2017, we got the Prism Award, which is one of the most renowned recognitions from SPIE. If you go to Photonics West, and probably you will go at some point, If you haven't, this is one of the major events during Photonics West. 2018, we decided with my associates to start Goya Lab, which is still running and offers new generation spectrometers. We're still using the smartphone, but now we have a more advanced spectrometer which can have added functions like illumination. If you want to excite and you want to do fluorescence studies, for example, this is what you can use. So at this point, my advice to you is, if you have a taste for entrepreneurship, do it, but not necessarily soon, okay? You want to have a little bit of experience before you start in the entrepreneurship, or if you really want to go straight to entrepreneurship, do it with experienced associates. I didn't mention, but with Alphanov, I accompanied a lot of entrepreneurs. I supported about 20 startup creations, and sometimes you see young students, you know, full of energy and enthusiasm, but yeah, sometimes they lack a little bit of maturity to make their project a success. So if you don't have this experience, at least get it with your associates. Like I said, you want to go to the market as fast as possible. You want to be ashamed of your product, your product, when you put it on the market. And it's not to say that it will stay like that, because putting it on the market is a good way to get feedback and to continue improving the product, to do product development. But the best way to do product development is to have real feedback from customers. And there are many ways to do this, right? If you're interested, of course, you can always contact me and I can give more details on that. Try to get recognitions. Of course, I talked about publishing. That's great if you're a researcher, but press articles are great. Try to get awards, etc. There are many ways with social media these days. And yeah, my last advice is be ready for blood and tears, because entrepreneurship is not easy. I will not lie to you. It's a lot of work. It's often you get what you want after a long time, so you need to be patient, but it's all worthwhile if you ask me. So I think I'm pretty much on time, and if you have any questions, I'll be happy to answer at the end.
Okay, thank you very much, Arnaud, for this very interesting talk. I am not sure that Laetitia can talk, but okay. And congratulations for the Goya Lab. So now, Mircea, if you are ready, we can hear you.
Hi. Hello, can you hear me?
Yes, perfect. You can share your screen.
If I can share the screen. So, can you see it?
Yes, it's okay. Thanks.
Okay, great. Let me see if I should see also my window. Yeah, so thank you first of all for inviting me, and thank you, Arnaud, for actually very nice opening on the maybe larger picture of entrepreneurship when you come from industry, and you already put some entries for me on what's maybe not ideally in academic entrepreneurship. So my job would be actually to show that, and the purpose to show that, yeah, actually it is possible to come up with good ideas and push them all the way from the academic research to spin-offs, startups operating in their own environments, but really benefiting of being seeded by the basic research, being nourished or helped to grow in academic environment, and then eventually making a big impact in the commercial world. So a few things about myself. So I'll not have much time. You can check my LinkedIn and there are things on the internet. But I like to introduce our group. The group I'm leading is Optoelectronics Research Center. We are actually a part of a photonics laboratory in Tampere, a rather large community of various fields of optics and photonics, basic science to technology. What we do molecular beam epitaxy as a core technology, and we push this then from material research, purely material research, to doing devices, and we are working on various classes on solar cells, photonic integration circuits, a lot of semiconductor laser diode, non-classical light sources, and so on. And occasionally, or maybe not occasionally, but in a sense that it happened random, but in the sense that it cannot happen too often, we are able to push the research all the way to the application and then identify very good needs and fit of our technology to real problems. One more slide of what we are doing. Actually, we are one of the largest optoelectronics research groups in Europe in academic environments. We are about 32 to 35 people, new students getting in, working in this area. And what is maybe special about our environment is that we are covering a rather broad range of semiconductor material, compound semiconductors, 3-5 materials, gallium arsenide, indium phosphide, gallium antimonide. And then we have a sort of vertical integration strategy. So we are able to do the design of the heterostructure, grow it, fabricate it, whether it is a laser or a solar cell or a detector or a single photon emitter, then characterize it. Then we are now putting a lot of more attention on topics like linked to photonic integration and then making system on chip, which is very topical for Europe. And again, then some of these topics can evolve to all the way where you can really see a big differentiation. And differentiation is actually one of the first inputs which I like to share with you from my experience as an entrepreneur. I will tell you a little bit more of the spin-offs I have been involved with. They all share a model of creation, which is bootstrapping. So actually having a strong differentiation, a very strong skill set, and then going to the market, maybe not when you are fully ready. I'm not sure if being ashamed, it is the right thing in our case, but I would say that being ready to serve at least the first-hand customers. Someone is really able to pay something, and that is a good sanity check for having a value. Now you see, and then again, well, Ticia and other colleagues and students know that we are doing a lot of things, and that is often we are asked, or I am asked, why do you do so many things? We have actually 4 MBA system and a lot of projects and so on. It's actually not really a matter of choice. There is no other way. The technology research and particularly when you really think how to make it to the market, it's not very predictable. So we want to keep a good flow of research and preserve our expertise on the core technology with molecular beam epitaxy. And for that, we need a rather large set of projects. And we cannot always get material science projects, or we need to have device X and Y and so on. It's a semiconductor laser or a solar cell. From the technology point of view, it's more or less the same thing. And critical mass and long-term commitment, it's really the must and essential for doing spin-offs coming from this branch of photonics, really relying of multidisciplinary aspects from materials, devices, and application. And yeah, this is painful. We cannot always ride the nice topics which are coming, like, well, you have seen it's graphene and quantum, nanostructure, and non-linear this, non-linear that. So these are topics with good funding, which occasionally come. We have to stick to what we know, because if you try to reinvent ourselves every 5 years with a new hype of which goes in science, we cannot really build up and long enough development and build up differentiation. Now, From ORC, actually, we have a long legacy of a history of making startups. Already from 90s, end of 90s, the first startup spin-off was Tutcore. They were doing laser diodes for printing devices and for aluminum fiber amplifiers, 980 aluminum free lasers, and they were acquired by Coherent, and then one of the largest and then certainly most visible in the area of medical lasers company, it's Modulite. It has been founded in 2000, and it's very close to our university now, and very strong collaborators for us. They have been doing lasers for, and you can check, for very broad range of application, and then more recently, well, success is in the medical lasers. And then there have been other companies like Corelace, which have been acquired by Prof, Coherent, and now are part of 26. And then my experience as an entrepreneur links to Reflectron and Pico Photonics and Vexlum, and I will show you a few, just an intro slide, what those companies are doing, and tell you a little bit how they faced in terms of the research we were doing at that time. Reflectron actually started as a PhD thesis project. It was my PhD thesis finalized in 2002, where I developed semiconductor saturable absorber mirrors for ultra-fast lasers. And then I noticed that there is such kind of need. It was a really booming or emerging the need of ultra-fast laser then, but I did not have the skills to fabricate this. So my PhD was purely on laser physics, Modlock lasers. So I got, let's say, accepted. I realized that I need to learn something new in the postdoc. Well, Arno told this already. So for me, it was a very natural step to move to fabrication. And in the postdoc time, I have learned to make, well, to master molecular beam epitaxy for some type of devices. And since then, Reflectron has been providing customized semiconductor saturable absorber mirrors for ultra-fast lasers in various concepts. Now I am sort of away of the operation. It's a new generation of operational, let's say, team taking care of the company. And maybe I'll make a note here. So people are saying it's big company, small company. Reflectron is a small company because the market is small. It's a niche market, but there is no shame in serving niche market. There is a very big need, and in Europe there are only 2 companies doing this type of devices, which are essential for ultra-fast lasers, and then only one, Reflectron, focusing on customized project, not doing, let's say, commodity type of stock type of devices. And that's I think that as long as there is a need, it's okay to do what that market requires and enable it. So then we have established Pico Photonics in 2015. Pico Photonics, in a way, has been a side story from the experience in Reflectron, and we form a different, let's say, entrepreneur team, because getting people with complementary expertise and maybe having them to behave as an entrepreneur, it's very important. It brings a lot of energy, and it also cut a little bit of resources. It's easy. It's a sweat equity. If you get colleagues or people with the same type of spirit, you can bring a lot of resources to an early stage startup by the sweat equity, by their time they are putting in. So Pico Photonics is doing Q-switch microchip lasers for semiconductor saturable absorber mirrors, and in particularly based on semiconductor saturable absorber mirrors, and in particularly fitting these needs of pulse, energies, and duration between the mode locking and traditional Q-switch. And there are various line of application. We are emerging now from sort of stealth development and prototyping with several line of products in range finding, LiDAR, microscopy, time-gated Raman microscopy, and companies already operating in own fab and preparing for volume production. The most recent spin-off and then a spin-off with very good dynamics came actually after about 12 years of research on a type of semiconductor laser called VEXEL, vertical external cavity surface emitting lasers, to the point that we were really ready to serve first type of customers, research customers. They are always easier to engage with. And here it's Jussi Pekka, which is the CEO and CTO of Vexlum. I think that 4 years back when we were announcing this Photonics West. Now, I bring again the need of differentiation. Our differentiators come from the legacy and know-how on semiconductor technology. We can design wavelengths on demand. We have been working many years to understand this particular laser platform and then to handle things like power and then noise, which is very important for our application and where these lasers are used now a lot in quantum technology, quantum computers, lattice clocks, optical clocks, using trapped ions and neutral atoms. And I think that we see this growing very fast, and I think that it will be a very nice example of new type of laser technology making a big impact on the various commercial markets. Now, how this have started? So I think that the first thing it is to not forget the legacy. I mean, yes, I've had my own role here. All of these have been either early stage project like PhD or postdoc project, or then the first professor projects and so on. But first of all, you had to have an example, and you have to really decide how do you want to do. And in that decision level, what also Arno said, okay, what do you want? You are academic or industry. Actually, having examples is very good. So there is a certain positiveness in the power of example. And in our case, it's Professor Marcus Pesa, which he is the father of the established group and the ORC group back in 80s. And he was behind the first companies, and I got the chance to work with him as a PhD student, and actually he recruited me from Bucharest to start the PhD in Tampere. And I really like his philosophy and search for purpose, and seeking purpose of research beyond curiosity, beyond what typical academics do, and then pushing it all the way, having determination to create the means for that. So I'm actually lucky. Now I feel very lucky. I felt also then, but then back in 2009 when Marcus retired, I felt overwhelmed to take and lead his group when on the semiconductor part of his group when he left. But I think that I think that we managed to follow in his path of success when it comes to taking basic research to something useful. Now, a little bit of university environment for entrepreneurs. So, well, we talk about innovation, which typically is invention, where universities are good, and then commercialization. So academic research fits very nicely here. Entrepreneurship, it's really, it has own struggle. It's not easy when you are starting as a pure entrepreneur in your garage. It's not easy when you are also operating in the academic environment where you have a lot of other demands, like teaching and making the science paper and writing the projects and all these things. Now, what it helps in our case, it's exactly this is continuation of the input one. it's technology. So if you are able to preserve a critical mass of technology and build up expertise, the technology is really cumulative. It acts like a battery. It may be sometimes feeling that you are not in the wave of the hottest science, but it's also cycling. So whatever it is, many of the topics that are now, for example, very fashionable, they have been earlier and then also noticed, but maybe something else was missing. So I think that this is that technology, investing in technology, having long-term roadmaps, understanding what you really provided differentiation at a very early stage when you write your even PhD research plan, and that really helps. And then there are many things to happen. So yes, if you have the differentiation and you have made the good sanity check, when are you ready to make the jump? I don't know. There is not clear recipe for this. So, but in my opinion, is sometimes, at least as I perceive it, it's you feel it is like parenthood. You feel that you are ready, and well, first of all, you should feel it that you need it, you want it. You cannot be a good parent if you don't want kids. Of course, it can happen, but it's a lot easier if you really want it, and then if you feel it. And this feeling has many meanings, and a lot of it has to do with what you have around. In my case, students, then postdocs, then entrepreneurs. What you are able to identify and connect to and share certain vision, and then in the end, they are the one which are taking it faster. And in this process, you have to ride this valley of death, what you are seeing. There are many steps what you have to do. In our case, all of, well, maybe the reflecton, but the reflecton is maybe small and niche, but all the others have been more than 10 years of push in research before really we find this equation of differentiation and need and addressing the market. And yes, this is actually what it happens typically in academic. You have to have the research, you have to have the basic research part. And we start typically with Finnish academic programs, ERC programs, proof of concept, validation in real environment. But here at this point, you should already start working with some industrial partners. And then there is commercial exploitation. And you cannot really go there if you didn't pay attention to talent and identifying people. Well, it could be the experienced people from outside, but in our case, we build up the entrepreneurial team at this point, having students which are self-motivated. They can already indicate, as in our case, like in the Vexlum case, Jussi Pekka wanted to be an entrepreneur. He did say he didn't want to be a PhD student when at that point. Okay, he is pushing for that also. But I think that this is very important, and maybe what has been specific in our case, we have been able to maybe break this interface. And in terms of management, conceptually, I can tell you that there is not a big difference between being a CEO or a group leader, because idea of pitching for the funding, idea of finding purpose, ideas of understanding competition fundamentally are the same. In my opinion, some of the most successful scientists will be also very good for being a very successful entrepreneur. But for a reason or another, not everyone are really making going through this interface. Now, something which is maybe unspoken, but I tend to tell the messages as I feel it. So I don't really think that universities are supporting entrepreneurship at large. I mean, of course, there could be cases, case by case, and this is maybe too big generalization, but one very clear input is that there is no metrics to the groups. If you make a spin-off or 2 spin-off or 3 spin-off, you will not get maybe, well, some moral recognition, but there is no one is coming to say, well, saying now 5 people of your group have left to a spin-off. Now we help you with some resources to replenish your group. It's not like that. It's a pain. And as a group leader, you have also have to think a little bit about that. Then innovation concepts are really followed only at a very early stage. Well, if you are not MIT or Stanford or ETH or maybe some other examples, no one is really covering the patents for 5 to 10 years, as it may take to really become obvious and when you come from very early stage and technology research to application. So you have to worry about that. The very positive things, and in particular in Finland, is that there is more and more awareness that infrastructure, academic infrastructure, very expensive equipment needs to be more available to industry, because small spin-offs can, if we talk again about high-tech hardware, semiconductor technology, other type of technology, you cannot, let's say, you will have a lot of burden if you have to invest 5 to 10 million to just make some prototypes. So this is working very nicely, at least in our case. And this is, for example, there is such kind of national infrastructure for providing access to expensive instrumentation, at least for the prototyping, for the early stage. And for example, in Finland, we have the Crane, which is the flagship program, which brings the key players and their infrastructure in a sort of transparent way. There are struggles always to find out the models, but nevertheless, it works. And I think that I wanted to stress that it's very important. Now, instead of conclusion, I think that generally there is no clear equation. Personally, for being successful in entrepreneurship, I really don't think that someone can teach you to be an entrepreneur. Equally, I don't really think that someone can teach you to be a leader. No, there are certain models, certain things what you could follow, but if it's not coming from you, if you don't have the desire, if you don't have the patience, if you don't have the respect and understanding for the team and a lot of common sense of leaving a system to grow around you, and then a lot of common sense to react to the markets, to the customers, to competition and so on, it doesn't happen. I mean, you cannot really learn that, but well, there are people which have all those things, and then I think that our job as first of all, as educator, as academic environments, professor in my case, I think that in my case, the best output, what I would count when I will retire, will not be the number of papers. There will be always more professors with better papers and higher number. It's not the number, but if I could help that there are more of those examples of long-term research pushed all the way that becomes useful, and you see the value by someone paying for it, and then having people really filtering and enabling this filter. Basically, university it's at this point a filter, so it filters for entrepreneurs or scientists or engineers, and it's their exam. I think that that's really something which I would count.